So I have Dave Patterson here, who is a professor at Berkeley for 40 years, won the Turing Award with John Hennessy for RISC, the RISC processor. Also had Angelina Jolie call out to RISC in one of my favorite movies and a
Turing
formative
Award,
movie for
Angelina
me.
Jolie, they're right up.
Hackers. So since retiring from Berkeley, spent nearly 10 years at Google working on things adjacent to AI. And you've teamed up with me and Laude in the last 2 years to work on a Moonshots grant program. So you've long distinguished career, also co-author of the textbook on architecture, and you're an architecture by background in your research area. What did I miss in your bio?
No, you've got pretty much.
Got the highlights?
Yeah.
Okay. Thanks for chatting on camera. And
sure.
Cheers.
Cheers.
To a great day. Maybe hide our labels like they do in Hollywood unless they pay us. Tell me about the Moonshots.
Well, when we were writing the Shaping AI paper and bring together a really strong team of co-authors, as part of that process to get AI researchers to do projects that help the public, raising the upsides of AI, reducing the downsides, we thought it'd be interesting to identify some moonshots for the AI researchers to shoot at. And one of them, like which one we should pick, and then we talked it over with AI, you could do a lot. And so we picked 4, and then last Thanksgiving, we put out a call for papers to see who would respond. We really didn't know what would happen, and we were thrilled to get 125 proposals from all the top institutions in North America.
What are the 4 that we landed on?
It was health, improving healthcare, accelerating science, when people lose their jobs, to reskill them to get other jobs, and then improving civic discourse. We got an overwhelmingly response, not only in numbers, but in quality. We had a world-class program committee evaluating them, including Turing laureates and a Nobel laureate. And they kind of all, I think everyone mentioned, well, these are much more interesting proposals than we've seen in the past, is that by getting people to raise their sights to try and shoot for the moon, they have to be intermediate steps of the way. They did more ambitious things that might have even greater impact. And this is going on in a context where these kind of reconsiderations of government funding by the federal government. And one of the complaints were just not enough ambition, not getting younger people involved with the current practices at the National Science Foundation and other agencies. So, we're trying this new path, and it shows some signs of being different from what's been done in the past in a very positive way.
And you skipped the part where we first met at Schmidt's pub in Berkeley and had the idea together, where we had Guinness.
I'd say you had the idea.
I pitched you on an idea, and what we decided that day is pretty close to what we've done. And we also had beer that day, so here we are having beer again. That's why 2 years later.
That's why we're refreshing ourselves with beer. Yeah, you wanted to get more people to have the experience you had as a grad student in one of these Berkeley-style labs. High impact was the main goal. Papers were secondary. And that AI was this opportunity for us to target. And back when you were a grad student, we wrote this visionary paper about cloud computing, which was controversial at the time. You thought we could do it again, and we've kind of exceeded expectations. We wrote a technical report that was widely read.
That had a lot of famous authors on it.
Yeah, we had John Hennessy,
Jeff Dean,
Tino Cuellar. We interviewed Obama and
John Jumper, who just got who won the Nobel Prize right after we interviewed him, or right before? I can't remember. Right after. And
we wrote a paper. It was reprinted or revised in the Communications ACM on the cover of that.
And you had like a little piece in The Economist, too, about it.
That's right, to try to get the word out. But we had a bunch of goals, which is, be in a popular magazine, get an influential paper, get it published, be it out there, get a strong committee, interview a lot of people, and then go on from the moonshots to try and get people to work on the moonshots. And I think in kind of every target, we've exceeded expectations.
And now we're on to the fundraising one.
And now we've launched 25 different groups. We've given them seed grants, and they're supposed to come back in 6 months to show progress. And we're going to be trying to get philanthropists to donate money to fund these 3-year, $10 million labs, and we're on this adventure to see how well we're going to be at philanthropic fundraising.
And in the meantime, since I've written the first check, you wrote the second check.
Yes.
And we're
that's right.
lining up the third and fourth checks coming in from
That's
other successful technologists who are distinguished in their careers and have been lucky enough to benefit from the impact of the systems that we build in the world. And that's a theme here.
As young as I think I am, I still have got 50 years in the field. So I feel those of us who have been around a while, it's up to us to preserve the opportunities for this next generation. And I think those of us who can afford it ought to, not just set an example by caring about the issue, but by donating some of our wealth like you have. And so I'm hoping several people who are famous for their contributions to computing and AI will also support Laude with their paychecks.
Yeah, well, thank you for doing it yourself. Let's see, what else? What else should we chat about?
I'm struck with, at one hand, how much hardware we need to be able to do AI research. On the other hand, talking to some colleagues at Berkeley, applying AI, it may be that we can get away without having to buy thousands of GPUs for our own use, that we can spend the money on tokens, which are kind of affordable. There was a talk to an assistant professor at Berkeley in architecture, and he's able to do really interesting research and, at the cost of thousands of dollars spending it on tokens, because, the subscriptions are kind of surprisingly affordable. So that was kind of an insight, because both of us were worried that if the minimum ante is 1,000 GPUs for any graduate student, this is going to break the bank. But if there's tasks that researchers can do that doesn't require them to get a data center worth of GPUs to be able to do that, that's promising.
Yeah, so you would encourage researchers, and you're heartened to talk to researchers who are focusing on areas of applications, but any type of impact they might have where they're not needing hundreds of millions of dollars of resourcing or funding, which is kind of the table stakes for large-scale training.
Yeah, when I think about it, my personal history, those same tremendous costs, you could argue, were true for computer architecture, microprocessor design. Intel and companies like that, where they would spend $100 million designing a microprocessor, and when people at Berkeley and Stanford were trying to design microprocessors. So if we did exactly the same thing that they did, we couldn't win, but we came up with a different set of ideas, and were able to take advantage of government funding to build prototypes of the ideas that were very convincing. They weren't products that you could ship, but the prototypes were so convincing that commercial companies followed in the wake of that, and the RISC architecture became very popular. Even though, in some sense, we're off by factors of 1,000 in how much money our competition had, we still did something different and was able to have high impact.
Yeah, that reminds me of two things. One, that we had a similar story for cloud computing in the RAD lab, where is the lab that I worked in with you. And that paper we wrote was about the economics of cloud computing and how the public cloud would win because it allowed large organizations to buy resources where they didn't have to provision for the peak demand, and which was very inefficient for them. But we were saying at the beginning of that lab, where we did a lot of cloud research, that we were at a crisis because the Googles and Microsofts and Amazons of the world at the time were spending hundreds of millions of dollars on capital expenditures to build data centers, and there was warehouse scale computing, and we had this little 30-node RAD lab cluster, and we had to find in our scarcity ways to use like new exploratory approach to, I think that's the thing about academia. It's used to operating in a scarcity compared to industry, and it is better at exploring than where the closed labs often are better at exploiting, and at least now in the paradigm of AI.
Yeah. I mean, I can. The nice thing about being older, I can do time travel backwards. But we did our first retreat for the RAD lab, and the feedback we got was exactly what you said. From all the retreats we go to Lake Tahoe or some nice place like that, and we bring people from industry there. And the uniform feedback was, you guys, a rack with 30 servers is not the scale of your ambitions. That's unconvincing. So I remember coming back and so what are we going to do? Well, We could try to get donations for 1,000 servers and remodel space in Evans Hall and start trying to run a 1,000 server thing. That sounded pretty bad. And then there's this new idea called cloud computing. And so we jumped on that. We said, well, this way we can scale to 1,000 in a way we can afford. And we were one of the first customers of Amazon Cloud Computing to push the scale limit because of the advice that we got. So, there was a very, if we'd taken the advice directly, there would have been a very expensive way to do that. And it probably wouldn't have worked even if you had the money. But by seeing what we needed and jumping on cloud computing is this much more economical way to scale up to the thousands that we wanted for our software projects. There's a couple of examples from the past Berkeley labs where had the same kind of apparent financial disadvantage that we found alternative ways, and it led to better outcomes than if we'd had the money.
Right. Apache Spark, Mate created in Rad Lab, and we built a system called Mesos. Both of those were software operating systems that we could operate at a smaller scale, but then could be transferred over into industry, and large industry did pick them up and run them on clusters much larger than we were able to use to develop them. So parallel to the RISC kind of effect that you were talking about earlier. The second thing that it reminded me of was what Percy Liang tweeted yesterday, where they had in the Marin project where they're doing pre-training in the open. They have like a big focus in the research agenda is to give researchers a platform to try pretty new and different types of approaches to architecture and data mixes, and then a big focus on predicting the loss curve before you do the training to see if you can build a science that can actually do better simulation, better predictions of the outcome of your data mixes and your architecture choices. And they did a really high quality prediction before they trained 170 or 130, I think 170B model, that like a mixture of experts model, and they kind of hit their prediction right on after then going and spending order millions of dollars to actually pre-train the thing. The focus on creating a type of collaborative platform where people can try out ideas at the small before you have a few that kind of win in that level of competition to be promoted even to the next level up, which is still not ever going to be Google or OpenAI and Anthropic scale. But then those ideas, as they get vetted and you end up with a prototype or a demo, much like you did with RISC, that then can translate over into industry or startups or something.
Right, because there's this, I did detect this, throw up your hands, we can't compete with these guys, it's hopeless. But the one thing I can say about AI, it's unaffordable to everybody. I mean, there's this space race, so people are spending hundreds of billions of dollars, but this is not economical.
Hundreds of billions.
Hundreds of billions of dollars. Google, Microsoft, Amazon, and Meta this year are going to spend more than $700 billion in CapEx to data centers and chips. It's just because there's a competition and they're afraid to be left behind and they're first, but it's not because, wow, we'll spend $700 billion this year and we'll get this huge return right afterwards, right? So we need great ideas that make AI much more affordable. I think we've proven that it's valuable. Everybody wants to use it. There's some dangers, but it can make you much more productive, but the costs are just scary. So if academia with a lack of money can demonstrate how to get some of these same quality ideas much more economically, that'll be, award-winning research. That'll be something people will beat a path to the door.
And even research that the big players would have incentives to fund.
Oh, yeah. I'm a chip designer. I still want it to be more affordable. I like people to use my chips, but if we had 10 times the compute today, they have great ideas how to use it. So could we make computing a factor of order of magnitude more cost-effective for AI? That would be a huge boon.
So you have a long trajectory perspective in your career in research, and I'm curious if you could use that perspective to talk about the state of academic research and the intersection of academic and industrial research. This conference is bringing together kind of half and half. NeurIPS has blown up in scale and size, the kind of premier AI conference, but also has a lot of attendees from closed labs. Do you see that the dynamic between industry research and academic research has shifted at all, or does it feel pretty similar to how you experienced it throughout your career?
I've been in architecture area. So over the decades, things have changed. I mean, when I started in architecture, industry and academia both went to the conference and talked about what they've done. I think over the years, industry has participated less. I think there, in some circles in architecture, they appreciate industry less. For me, it was you have ideas, but eventually these ideas, somebody has to use them.
You mean in academic circles of architecture where they're designing the
academic,
chips?
we can't just keep it all internal, right? Eventually it must leak out and somebody use it in a product. So I've always treasured the relationship to industry and to see them use their ideas and understand what their problems are. I think what's happened in machine learning over my decade at Google, it used to be publish first, right? That was, in fact, companies that didn't have a tradition of publishing couldn't hire ML people because they needed to publish. And then somewhere 4 or 5 years ago, they decided this stuff is so valuable is that publishing was going to get a lot harder. But it hasn't always been this way. So that's been a pretty big change. But there's not, like in some fields, not in computing, but in some fields, there's this rivalry between industry and researchers, is that academics see the people in industry as selling out, and the people in industry think of the academics as an ivory towers working on things nobody cares about. And so they have this antagonistic relationship. I don't think that's true here. I think there's still this desire for collaboration, appreciation of what work's done. But I think it takes conferences like this will help figure out what's the roles each can play to to their best use.
And you were distinctive in your approach, especially 20, 30 years ago, in bringing industry into the lab every 6 months to give feedback and inform artifacts that the labs would build that were prototypes and proofs of concept of potential impact, what could become technology transfer. You created a lot of fertile ground for that tech transfer. So you have a biased perspective just in how fruitful industrial collaboration can be as an academic. I think a thing worth talking about briefly here at the end is how does it feel like it's going as we encourage in research labs across all the top universities outside of Berkeley, outside of your direct legacy, to do similar things as we talk about funding them with the Moonshot grant program?
To me, it was just common sense. The people in the industry went to our former students, right? They're not aliens from another world. They're smart people, and they've got lots of experience that's different than yours. And if the ultimate goal is eventually for people to use your ideas in this industrial world, why not take advantage of the opportunity to have them and give you feedback along the way? It's just hugely beneficial, rather than you submit a paper and 9 months later you get 3 or 4 reviews, each 1 page, and that's in sometimes pretty poor quality reviews. Here we could get 3 days twice a year with these really smart people. It just felt like this. I don't know why everybody's not doing this. This is a huge opportunity to get better work out of it. I still feel that way. And fortunately, as part of our Moonshot program, we've talked to some of your colleagues, alumni, and they've had a hard time getting the retreats. They say, well, I'm in the Midwest, I can't get people to come out. So part of the Moonshot program will be, okay, well then if you can't get them to go there, you guys fly out here and we'll have the retreats here where we did.
In the Bay Area.
In the Bay Area, like when you were a grad student. But getting feedback from these really smart people who have different experience to you is just vital to the success of these kind of projects.
So one way or another, we're going to require that these research labs at other top universities besides Berkeley that have won this funding from us bring industry into their lab in a way that people have tried. My peers who went from Berkeley in my cohort and went off to CMU or MIT or other schools weren't able to kind of pull off. And that's one of a handful of ways that we're being very opinionated in the types of labs that we fund.
Yeah, there's this interesting kind of alternative universe. What's the legacy? If you look back 5 or 10 years with the Legacy Moonshot program, it might not be the people we fund. It might be by setting the moonshots and getting these people to cross disciplines and work together and come up with a provocative idea. That might end up being what the contribution of the Moonshot program is.
Yeah, right. And it is, and that way we're architecting at the institutional level because we figured out an incentive mechanism that got great minds to come together and get some skin in the game just to write the proposal. And once they've written the proposal, even if they don't get the grant from us, we will give grants out, obviously. They'll go get it from someone.
Presumably, these people are genuinely excited about the topic. They want to make it happen as part of the proposal writing process. And then whether or not they get money from us, they're going to pursue this. And that would be a very exciting legacy if that's true.
Great. Well, I think that almost wraps it. That's a good spot to end, because I think that the time that that these folks that we're calling these folks to moonshot action, I think part of why they're getting so excited is a time when it feels that the current paradigm is at species level, like it's changing so many parts of society. And so what better time to be a researcher and do a moonshot than when maybe the technology is there to let you have species level impact.
You want to be a researcher at a time when there's exciting opportunity. When things are slowly changing and making lots of money and not innovating, that's not a time to be a researcher. This is an amazingly good time to be a researcher.
So you've seen a lot of paradigms, you've authored formative technologies in them, but I couldn't have picked a better one to team up with you on than this one as we kind of write our children's legacies.
We've said this before, like in my career, once a decade, like microprocessors, personal computers, the internet, smartphones, and now AI. And AI is going to be the biggest one.
Well, here to the grand experiment we're running to make sure it goes the right way.
Okay.
All right. Thanks, Dave.
All right.